Hello, welcome to how to solve this very nice exponential equation. 4 to the power n plus 3 to the power n is equal to 91. We need to find all possible values of n. We can write this 4 to the power n as 4 to the power n whole to the power 1 plus we can write this 3 to the power n as 3 to the power n whole to the power 1 is equal to 91. Now 1 is equal to 1 over 3 times 3. So we replace this one and this one with this 1 over 3 times 3. Like this, 4 to the power n whole to the power, we replace this one with this 1 over 3 times 3 plus 3 to the power n whole to the power, we replace this one with this 1 over 3 times 3 is equal to 91. Now according to this power rule, a to the power m whole to the power n is equal to a to the power m times n. We multiply this power n by this power 1 over 3 and we multiply this power n by this power 1 over 3. Like this, 4 to the power n times 1 over 3 n over 3 whole to the power this power 3 plus 3 to the power n times 1 over 3 n over 3 whole to the power this power 3 is equal to 91. We suppose that let 4 to the power n over 3 is equal to x and 3 to the power n over 3 is equal to y, and we substitute x and y in this equation, then this equation becomes x cubed plus y cubed is equal to 91. Now we can factorize this x cubed plus y cubed as x plus y times x squared minus xy plus y squared is equal to 91. Now we have two factors at left side, and this 91 can be factorized as 1 time 91, 7 times 13, 13 times 7 and 91 times 1. Now because we are looking for positive integers, therefore x and y are positive integers. It means x is greater than 0 and y is greater than 0. So this expression x plus y will be smaller than this expression x squared minus xy plus y squared. So we reject this case because 13 is greater than 7, and we reject this case because 91 is greater than 1. We have only two cases, 1 time 91 and 7 times 13. And first we solve this case 1 time 91. In case 1, we write this x plus y times x squared minus xy plus y squared equal to 1 time 91, and we write this smaller factor x plus y equal to this smaller factor 1, and we write this greater factor x squared minus xy plus y squared equal to this greater factor 91. Like this, x plus y is equal to 1 and x squared minus xy plus y squared is equal to 91. Now we take square of both sides of this equation. X plus y whole squared is equal to 1 squared. This x plus y whole squared is equal to x squared plus 2xy plus y squared is equal to 1 squared is 1. Now we subtract this equation from this equation. X squared plus 2xy plus y squared is equal to 1, and we subtract these two equations. And because we are subtracting, the signs of these terms will be changes. This plus becomes minus, this plus becomes minus, and this plus becomes minus. So this positive x squared will be cancelled out with this negative x squared, and this positive y squared will be cancelled out with negative y squared, and this negative 1xy minus 2xy minus 3xy is equal to 91 minus 1, 90. And if we divide both sides by negative 3, then this implies that xy is equal to negative 30. Now because this x and this y both are positive integers, x is greater than 0 and y is greater than 0. So the product of two positive numbers cannot be negative. This is positive and this is negative. This is not possible, so we reject this case. Now we solve case 2, that is 7 times 13. In case 2, we write this expression x plus y times x squared minus xy plus y squared is equal to 7 times 13. Now we write this smaller factor x plus y equal to this smaller factor 7, and we write this greater factor x squared minus xy plus y squared equal to this greater factor 13, like this. X plus y is equal to 7, and x squared minus xy plus y squared is equal to 13. Now from this equation we take square of both sides. X plus y whole squared is equal to 7 squared. Now this x plus y whole squared is equal to x squared plus 2xy plus y squared is equal to this 7 squared is equal to 49. Now we subtract this equation from this equation. X squared plus 2xy plus y squared is equal to 49, and we subtract this equation from this equation. Because of subtraction, this plus becomes negative, this plus becomes negative, and this plus becomes negative. So this positive x squared will be cancelled out with negative x squared, and this positive y squared will be cancelled out with negative y squared, and this negative 1xy plus negative 2xy negative 3xy is equal to 13 minus 49 negative 36. This implies that xy is equal to 12, and from this equation x plus y is equal to 7, x plus y is equal to 7. If we find the value of y, then y will be equal to 7 minus x. Now in this equation we put the value of y 7 minus x from here. Then this equation becomes x times value of y is 7 minus x is equal to 12, and x times 7, 7x, x times negative x squared is equal to 12. Now we move this negative x squared and this 7x to the right side. Then this equation becomes x squared minus 7x plus 12 is equal to 0. Now this is a quadratic equation and is factorable. So we solve it by factorization. We write this x squared as it is x squared, and we break this negative 7x as negative 3x minus 4x plus this 12 is equal to 0. Now from these two terms, x squared minus 3x, we can factor out x. So x as a common factor, and in bracket left x minus 3. And from these two terms, negative 4x plus 12, we can factor out negative 4. Negative 4 as a common factor, and in bracket left x minus 3 is equal to 0. Now as you can see, this expression x minus 3 is a common factor. So we factor out this x minus 3. X minus 3 as a common factor, and in bracket left this x and this minus 4. In bracket left x minus 4 is equal to 0. Now from here, either this expression x minus 3 is equal to 0, or this expression x minus 4 is equal to 0. From here x is equal to 3, and from here x is equal to 4. Now recall that y is equal to 7 minus x. Recall that y is equal to 7 minus x. Now when x is equal to 3, then y will be equal to 7 minus 3, and y is equal to 7 minus 3, 4. So from here we get first pair x comma y is equal to 3 comma 4, and when x is 4, then y will be equal to 7 minus 4, and y is equal to 3. So from here we get second pair of x comma y is equal to 4 comma 3. Now recall that we have supposed that 4 to the power n over 3 is equal to x, and 3 to the power n over 3 is equal to y. We have supposed that 4 to the power n over 3 is equal to x, and 3 to the power n over 3 is equal to y. So first we replace this x with this 3, and we replace this y with this 4, like this. 4 to the power n over 3 is equal to 3, and 3 to the power n over 3 is equal to 4. Now this 3 has power 1 here, and this 4 has power 1 here. But in this equation, at left side we have base 4, and at right side the base is 3. And in this equation, at left side the base is 3, and at right side the base is 4. So due to different bases, no integer solutions can be found from here. Now in this equation we replace this x with this 4, we replace this y with this 3. So 4 to the power n over 3 is equal to 4, and 3 to the power n over 3 is equal to 3, and this 3 has power 1, this 4 has power 1. You can see that at left side the base is 4, and at right side the base is 4. So we can write this n over 3 equal to this one. n over 3 is equal to 1. And from this equation, at left side we have base 3, at right side we have base 3. So we can write this n over 3 equal to this one. N over 3 is equal to 1. And from both of these equations, n is equal to 3. This is the value of n. This is the final answer of this equation. Now let's verify this value of n by putting this value in the original equation. The original equation is 4 to the power n plus 3 to the power n is equal to 91. In this equation we put the value of n 3. 4 to the power 3 plus 3 to the power 3 is equal to 91. 4 cubed is equal to 64 plus 3 cubed is equal to 27 is equal to 91. And 64 plus 27, 91 is equal to 91. You can see that left hand side is equal to the right hand side. So this value of n 3 is a valid solution.